Welcome to today's lesson. We are going to look at estimating and rounding positive integer. When you are asked to estimate something, you are simply being asked in other way to round the given figure or the given item to the nearest a certain figure. So when we are estimating, you are not giving the actual value. You are going to give a figure that is nearer to whatever you are being asked to attain in that given manner. So we start by looking at how do we round a given figure. So the first question, we are being asked to round the numbers that we've been given as indicated. The first number we have is 86. You are supposed to round 86 to the nearest 10. So as you are rounding 86 to the nearest 10, then we need to get to have the knowledge of the place values. We need to identify which number is in the tens place value and which one is in the ones place value. So we start from the far right. So the number on the far right is the number in the ones place value. Then the next digit is in the tens place value. So when you are being asked to round to the nearest 10, then it means we are looking at the number in the tens place value, but look at the next digit that you have. If the digit is 5 and above, then the number is rounded upwards. But if the digit is below 5, by below 5, this is the digit could be 0, 1, 2, 3, or 4, then the number is rounded downwards. So we consider the number in the ones place value because we are supposed to round it off to the nearest tens. So the digit that is in the ones place value is 6, and 6 is a digit that is more than 5. So since it is a digit that is more than 5, then it means our figure is rounded up so that this 8 it changes to 9, and we get that 86 to the nearest 10 is simply approximately 90. So this sign here simply means that it is not the actual value, but it is an approximate value. So it means 86 rounded off to the nearest 10 is approximately 90. Another example we have, so we have 4,142 to the nearest 100. So we look at the place values that we have. So this is ones. So the digit in the hundreds place value is 1. Then we are supposed to confirm the digit in the tens place value. The next digit we have is 4. So we discover that 4 is a digit that is less than 5. So since 4 is less than 5, then it means our number will be rounded down. So this means that this 4 will not have an effect on this one. So what will happen is we will still have the first digit, which is 4, then our digit in the hundreds place value, which is 1, but the remaining digits are rounded down so that you are having the 4 and 2 being rounded to 0. So we get that when 4,142 is rounded off to the nearest 100, it is approximately 4,100. Another example, we could be having a number like 59, and you're told to round it to the nearest 10. So we are having 59. This means 9 is in the ones place value. Then 5 is in the tens place value. So we are the digit we are supposed to round is 5. We check the next digit, which is 9. 9 is a number that is more than 5. So being a number that is greater than 5, it means it rounds our number up. So if this is 59, then our number is rounded up, and 59 is rounded to 60. So 59 is approximately 60 if it is rounded to the nearest 10. Maybe one last example that we look at. So we are having 1,512 to the nearest 1,000. So 2 is in the ones place value. 1 is in the hundreds. 5, no. 1 is in the tens place value. 5 is in the hundreds. Then 1 is in the thousands place value. So we are rounding off to the nearest 1,000. So we consider the digit that is next. Our digit is 5, and we've already said if the digit is 5 or above, then it means this digit rounds off our figure up. So it means this is 5, it will round off our 1 to approximately, so the answer that we obtain is approximately 2,000. So when 1,512 is rounded to the nearest 1,000, the answer we obtain is approximately 2,000. So that is what is required of us when we are rounding digits. What you need to consider is your digit 0, 1, 2, 3, or 4? If it is between 0 and 4, then it means the digit will make your number to be rounded down. But if the digit is 5 and above, that is 5, 6, 7, 8, and 9, then it makes your number to be rounded up. So that is a rule that you have to keep in mind when rounding numbers or rounding the given figure or the given event that you have to be that you have in that given situation. So we can look at a situation whereby the leading figure is the one that is being rounded off. So we need to start by asking ourselves, what do we mean by this term leading figure? When we look at a leading figure, we are simply referring to the digit, the first digit from the left. So if we are having a number, like for instance, you have 245. 245, for you to identify your leading figure, then it means you identify which number is on the far left of that, which digit is on the far left of that given number. So like in this case, 2 is the digit that is on the far left. So this 2 in this case is what we are referring to as the leading figure. So we can have situation whereby you are rounding the leading figure in your process of approximation. So you could be asked to approximate but using the leading figure. When you are asked to approximate using the leading figure, the rule still applies. The first thing you need to do is identify the leading figure. After you've identified the leading figure, check the next figure. Is it more than 5 or is it less than 5? If it is less than 5, then it means your figure will be rounded down. But if it is more than 5, then your figure is rounded up. So it is still the same rule that is being applied, but in this case, you have to identify what is your leading figure in that given equation. So we look at some tasks that we are being asked using the leading figure. So we have the task on the board where we are asked to round each of the following using leading digit approximation. So the first number we have is 21. So our leading digit in this case is 2. So 2 being the leading digit, we check the next digit and we discover that the next digit is 1 and 1 is less than 5. So 1 being less than 5, it means it rounds our number down. So that 20, when we round using the leading digit, will be approximately 21. When we round using the leading digit approximation, we will obtain 20 as the answer. Then the next number we have is 29. So 29, 2 is our leading digit. Checking the next digit, we are having 9. 9 is a digit that is more than 5. So being more than 5, then it means we approximate it to 30. Then the next number we have is 136. Our leading digit in this case is 1. Checking the next number, we are seeing that it is 3. So 3 is a number that is less than 5. So it means it rounds off. It rounds our number down. So this means this will be approximately 100. Our leading digit in 857 is 8. Check the next digit, we are having 5. So 5 rounds our number up. So it means we are having 8 being rounded up, I'll get 9. So that when 857 is rounded using the leading digit approximation, we get 900. 5,600, our leading digit in this case is 5. Then the next number is 6. 6 is a digit that is more than 5. So it means that rounding this, it will round it up to make 6,000. Then next, we are having 92,104. Our leading digit in this case is 9. So 9 being the leading digit, we check the next digit, which is 2. 2 is a digit that is less than 5. So this means this will be approximately 90,000. Then finally, we are having 999. 9,999. Our leading digit is 9. And the next digit is also 9. 9 is a digit that is more than 5. So it will round our number upwards so that I have the 9 being changed to 10. Then the rest of the 9 are zeros. So 9,999 is approximately 10,000 using the leading digit approximation. Another question on the same could be, so we can look at the question together. We are being told to use the leading digit approximation to estimate the answers in the following calculations. The first one we have is 42 times 7. So we need to identify which one are our leading digits in each case. Like in this case, we are having the number 42. So in 42, our leading digit is 4. Then the next digit is 2. You discover that 2 is less than 5. So being the fact that it is less than 5, it will round our figure down. So it means that 42 will be round to 40. Then 7 has no any other figure before it. So we are only left with 40 times 7. And we get that 40 times 7 will give us 280. Then next, we have 95 times 326. So the first number we have is 95. The leading figure in this is 9. Then check the next figure. We get that the next digit, and we get that it is 5. So 5 rounds our 9 up so that we get 100 as the approximate value. Then the next number is 326. In 326, our leading digit is 3. The next digit is 2, and 2 is less than 5. So 2 being less than 5, it rounds our number down so that we get 300. So in this case, the approximate answer, the estimate answer to our calculation will be 100 times 300, which gives us 100 times 300 is equal to 30,000. Next, we have 29 times 4. So 29 times 4, we discover that in 29, we are having our leading digit as 2. The next digit is 9, and 9 is more than 5. So approximately 29 is 30. We get 30. Then multiplied by 4. So 30 times 4 is 120. Next, we are having 29 multiplied by 41. So if 29 multiplied by 41, then we check the first number, that is 29. Our leading digit here is 2. The next digit is 9. So 9 is a number that is more than 5. So it means it rounds our digit up so that we get 30. Then multiplied by 41, we discover that our leading digit is 4. The next digit is 1. 1 is less than 5, so it rounds our number down so that we get 40. So we have 30 multiplied by 40, and we are getting our answer as 1,200. So those are the approximations or the estimates to our answers when we are using the leading digit approximation. One more question. So looking at the question, whatever has been indicated in brackets is what we are supposed to round our digits into. So the first question or the first problem we are having, we have 2,493 divided by 103. We are rounding off our numbers, both numbers. In this case, we've been told to round off both numbers to the nearest 100. So in the first number, we have 2,493. So I'm supposed to check which number is in the hundreds place value. So we have ones, tens, hundreds. So 4 is in the hundreds place value. We check the next number to 4, which is 9. So 9 is a digit that is more than 5. It will round our number up so that I will have 2,500 divided by the next digit. The next number we have is 103. We are supposed to round it to the nearest 100. So we have ones, tens, hundreds. So this is the digit we are looking at. The next digit is 0. 0 is a number that is less than 5. So it means if I round off this, it will be rounded down so that we have 100. So we have 2,500 divided by 100, which will simply give us 25. Next, we have 159 divided by 12. We are rounding to the nearest 10. So this is ones, this is tens. So we have 5 in the tens place value. Then 9 is a digit that is more than 5. It will round our number up so that we get 160. We are supposed to use approximation. So this is 160. Then 12, this is ones, tens, so 1 is in the tens place value. The next digit is 2, which is less than 5. So it will round our number down to get 10. So we have 160 divided by 10, and we get our answer is 16. Then next we have 2,402 multiplied by 3,817. We are rounding to the nearest 1,000. So this is ones, tens, hundred, thousands. So we get 2 is the digit in the thousands place value. The next digit is 4. 4 is less than 5. So it rounds our number down so that we are getting approximately 2,000. Then multiplied by, we have ones, tens, hundred, thousands. So 3 is the digit in the thousands place value. The next digit is 8. 8 is more than 5. So it rounds our number up so that we have 4,000. So 2,000 multiplied by 4,000, we get our answer is 8 million. Next, we have 92 times 67. We are rounding to the nearest 10. So this means we have ones, tens, so this is the digit in the tens place value. 2 is less than 5. So being less than 5, it means it rounds off our number down so that we are getting 90 multiplied by 67. 7 is in the ones, 6 is in the tens place value. So we check this next digit, which is 7. 7 is a number that is more than 5, so it rounds our number up to get 70. So 90 multiplied by 70, we are getting 6,300. Then finally, we have 124 times 173, rounding to the nearest 100. So when we are rounding to the nearest 100, then we have ones, tens, 100. So 1 is in the hundreds place value, so that we have 2, which is less than 5. Being the fact that it is less than 5, it rounds our number down so that we get 100 times. The next number we have is 173. So this is ones, tens, 100. So 1 is in the hundreds place value. The next digit we have is 7. 7 is more than 5, so it rounds our number up to get 200. 100 times 200, we are getting 20,000. So one last example on approximation that we are looking at. So we have all here a group of 159 students is roughly divided into 19 groups. So we are asked to estimate the number in each group. So we are estimating the number in each group. So the whole year we have a group of 159 students. So the total number of students that we have are 159. Then they are divided into 19 groups. So we are having 19 groups. We need to find out how many students are in each group. So this means if we have a total of 159 students, then we need to get the number of students in each group. Then we take 159 divided by 19. When we divide 159 by 19, we get that 19 into 159, that is 8. Because of 8 times 19, that is 8 times 9 is 72. Right, 2 carry 7. Then 8 times 1, that is 8, plus 7, we get 15. Then when we subtract, we have 7. So we discover that groups will be having at least 8 students in each. So an estimate number, we said that estimation is simply giving a rounded figure. So it means that each group will have approximately 8 students. In the process of rounding off, we discover that the answer you get is not the same as the answer that is expected. So what does it mean? There is an error that is being obtained, or an error that will be attained in the process of you working out sums or problems using an approximated figure. So we want to look at the maximum error. So we have an example of this question. If I have 71 multiplied by 11, in actual sense, 71 times 11, this is what we are supposed to get as the answer. So I'll have 1 times 1, which is 1. 1 times 7 gets 7. Then we have 1 times 1, that is 1. Then 1 times 7 gets 7. So it simply means that 71 times 1 is simply 1. This is 8. This is 7. So 71 times 11, in actual sense, it is 781. But supposing I'm told to round my digits to the nearest 10. So if I have to round my numbers to the nearest 10, then it means 71 to the nearest 10 will be 70. Then 11 to the nearest 10 will be 10. So we are having to the nearest 10, then it means my approximated figure will be 70 times 10, which gives me 700. So you discover that 70 times 10 is 700, 71 times 11 is 781. 781 and 700, they are totally different numbers. So what does it mean? The difference between the two numbers that are obtained then gives us the maximum error. In this case, we are having 781 minus 700. So 781 minus 700 simply gives us 81. So in rounding off, 71 times 11 to the nearest 10 gives us an error, a maximum error of 81. So there is an error that will be obtained in the process of our calculation. So it means when we've rounded off 71 to 70 and 11 to 10, then we are getting 700. And the difference between the original working and the rounded off figure is 81. So this 81 is what we are referring to as the maximum error in that case. So we are asked to calculate the error in these numbers. We calculate the error if these numbers are rounded. So the first sum we have is 23 times 17. So when we round 23 times 17, then it means this 23, we are rounding to the nearest 10. So this means that 23, 3 is less than 5, so it is rounded down so that we get 20. Then 17, 7 is more than 5, so it is rounded up to get 20 also. So we have 20 times 20, which gives us 400. That is the rounded figure. But the original figure, we are having 23 multiplied by 17, so that 7 times 3 is 21. We write 1, carry 2. Then 7 times 2, that is 14. 14 plus 2, we get 16. Then next we have 1 times 3, which is 3. Then 1 times 2, we get 2. So when we add, we have 1 plus 0, that is 1. 6 plus 3, that is 9. Then 1 plus 3, which gives us 1 plus 2, that is 3. So we get that the original figure is of 23 times 17 is 391. But the approximated figure is 400. So approximated figure is 400, original figure is 391. So what is the error in this case? How do we get the error? Error is simply obtained by the difference between the two of them. So we have 400 minus 391, and 400 minus 391 is simply 9. There is something that we need to note in the process of working out the two sums that we've just worked out. We discovered that when we are working out 71 times 11, our answer, our error, we had an error of 81. But we are having 23 multiplied by 17, and our error is 9. So what can be noticed is in 71 times 11, the error is greater than when we are having 23 times 17. And what is the reason to having a very big error, or the error being huge in this case and our error being small in this case? So we have a very large error here and a small error in this case. And this is what we can discover, that when you are rounding 71, this one was less than 5, one was less than 5, so it was rounded to 70. This was a down, it was rounded down. 11, 1 was also less than 70, so it was rounded down to 10. So in both cases, the two numbers, all the numbers are being rounded down. None of them, not one is rounded up and the other one down. That is not the case in this equation. But what we are discovering is that the two numbers, all of them are being rounded down. But in the second case, we had 23 and 17. In 23, 23 is being rounded down to 20, but 17 is being rounded up to 20. So we discover that in one case, one of the number is being rounded down and the other number is rounded up. So the case will bring about a balance in between so that the error that will be obtained is small. But in this case, all the numbers are being rounded down. So it means the error that will be obtained will be a bit large. Maybe just one last example on errors that we have. We are calculating the error in the following. So we have 65 multiplied by 54. So the original figure that is expected, that is 65 times 54. Then we have 5 times 4, which is 20. We write 0, carry 2. 4 times 6, that is 24. 24 plus 2, 26. 5 times 5, that is 25. Write 5, carry 2. Then we have 5 times 6, which is 30. 30 plus 2, we get 32. So in adding the figures, we have 0 plus 0, which is 0. 6 plus 5, 11. Carry 1. Then we have 2 plus 2, which is 4 plus 1. We get 5. Then this one is 3. So the original figure that is expected is 3,510. But when we are rounding to the nearest 10, then it means we have 65. 5 will round our figure up so that we have 70. Then multiplied by 54, 4 rounds our figure down so that we have 50. So in rounding, we get 70 times 50, and 70 times 50 is 3,500. Then how do we get the error? We've simply said that the error is the difference between the two figures that are obtained. So we have 3,510 minus 3,500. And we get that our error is 10. So the error being 10, you still discover that this error is still small, and this reason is simple. This one was rounded up, but this one was rounded down. So you get a small error. Estimation is used in our day-to-day lives. In so many occasions, in so many cases, we have to get to estimate. When you are going out for shopping, maybe, and you've carried some cash with you, you are simply estimating. You may not be knowing the original prices or the exact prices of the items you are going to buy. So what do? You are thinking of, I'm having 1,000 shilling, or I have $1,000. So if I have this $1,000, I need to go and buy some items, maybe some fruits, then buy sugar and so many other items from that $1,000. Then what does it mean? You'll have to estimate the prices of items you are going to buy so that they will fit in the whatever cash that you have. You'll have to estimate, maybe I'm going to buy fruits worth $50, I'm going to buy sugar worth $100, and so on. So you have to estimate the prices of whatever commodities you're going to use. Alternatively, the government estimates, in most cases, it estimates the population of the people in that given country. Why? Because it needs maybe to calculate the tax that will be collected from these individuals so that this tax can be divided into various activities in that given country, and so on. So we discover that rounding and estimation is an activity that we carry out in our day-to-day life. So what does it mean? It is very much important to know how you are rounding. If it is, in this case, if one figure is being rounded up, then round the other figure down so that your error that will be obtained will not be so large. But when you round the figure in the same direction, maybe all of them down or all of them up, then it means you're going to obtain a very big error. And this big error will bring about some mistakes in your calculation and so on. So you need to make sure that in the process of estimation of your figures, you are going to obtain as small error as possible. So that is all to do with approximation or estimation and rounding of positive digits. We've been looking at integers, and in the process of looking at integers, we've looked at 4 operations. That is division, multiplication, addition, and subtraction. So when you're having the 4 operations, there are some cases whereby you will have a situation where all the operations are involved, or a various of these operations are involved in the same sum. So what do? We need to have an order in which you are going to work out your operations. So this is where we apply the BODMAS rule. With BODMAS, what do we mean? This is, you will start with, if your sum has brackets, so it means we start with brackets, followed by off. Then if there is a division operation, then you go ahead and divide. Then from division, we move to multiplication. Then we have addition. and finally subtraction. So this is the order in which we work out the operations in case they appear in a question. More than one operation has appeared in a question. So we just look at a few examples that involve more than one operation in a sum. A simple example to start with, we have 6 plus 10 divided by 2. So in this case, we have to check, do we have brackets in our question? And we discover that we don't have brackets. So the next operation we have is division. So division is the first activity that we'll carry out. So we have 10 divided by 2. 10 divided by 2 is 5. So this means that we will have 6 plus 5. So the next operation we are going to carry out is addition. So we'll have 6 plus 5 gives us 11. You find that there are some cases whereby somebody might assume the order of operation and decide to work it out just the way the sum has been written. In this case, we have 6 plus 10 divided by 2. So that if this person decides with addition, starts with addition, then it means 6 plus 10 will give me 16. Then divided by 2 gives us 8. And you find that this is not the same as whatever we have. So it is very much important for us to get to know the order of operation. If we have a bracket, that is the first operation we will carry out. If we have off, then we calculate off. Then if we have division, multiplication, and then later on we deal with addition and subtraction. So in this case, you have to start. This one is wrong, but the order of operation that gives us the right answer is in this case. So the second example, we have 3 times 72 divided by 12 plus 1, but these ones are in bracket, then minus 1. So we said we start with what is in the brackets. So in this case, this is what I have in brackets. And checking in that bracket, we discover that in the brackets, we also have more than one operation. So inside the bracket, I need to start by the operation that is the first one to be dealt with, which is division. So I'll have 72 divided by 12. And we get that 72 divided by 12 is 6. So I'm still not yet through with this bracket. I have to wind up the calculation in that bracket. So I'll have 6 plus 1, which is still in that bracket. So 6 plus 1 gives me 7. Then next we have 3 multiplied by the whole of this bracket we've worked out, and it is given as 7. So it is 3 times 7, then minus 1. So we cannot work out subtraction before we work out multiplication. So the next operation we are going to carry out is multiplication. So we have 3 times 7, which gives us 21. Then finally we carry out subtraction, which will be 21 minus 1, which gives us 20. So what are we saying? We are simply saying this, that it is very much useful, it is very much important for you to follow the order of operation. There is no way you will start from an activity that is going to interfere with the rest of the activity. So what do? You will always start a procedure. There are some procedures whereby you cannot skip a step. So what you are supposed to do is simple, follow the order of operation. So in following this order of operation is check your problem correctly or confirm it very well so that you find out which order of operation are you going to work out first. If you are having brackets, then deal with the brackets first, followed by of, division, multiplication, addition, and then subtraction. So this marks the end of this lesson, and we hope that in the process of calculation, we are going to be very much careful so that we avoid errors that can be obtained through the wrong calculation. So can we just use the correct order of operation for us to obtain the right answers? Thank you.